Greetings, math fans. All right, so this is day 3 of chapter 3, and basically what we're doing today is, the first part at least, is I'm going to give you guys a graph, and you're going to construct a slope graph of that function. So I'll tell you, this is so key right here, is you got to look at, basically you're creating a slope graph. So it's very simple. So if I look at what I got here, math fans, okay, I've got the graph, which is my first graph here, and then I'm going to give you create a slope graph for the second graph. So let me move this into place here. All right, so here's the deal. This y-axis right here for the f of x graph, we like to say this is y units. Okay, and then this y-axis are slope units. Okay, slope units. And this x-axis is just our x-axis, and this is our x-axis. So that's the same. All right. So literally, let me label this now. This is 1, 2, 0, negative 1, negative 2. All right. And let's label this here too. 1, 2, 0, negative 1, negative 2. So if I ask you what is a slope, and let's actually label these. We don't necessarily need to because they're kind of the same, but it's okay. So we can kind of keep track of things. Okay. So I'm just going to change the color of my pen here. If I said, what is the slope between 0 and 1? Well, you guys know slope is what? Rise over run, right? So what is the slope of between 0 and 1? Do you guys agree that slope is 1? So what I'm going to do is I'm going to graph at 1. I'm going to do this. There we go. That's my first graph. And some of you guys are like, Mr. Griffiths, what are you doing there? You got those, what are those holes for? Well, if I ask you, what's a slope right here? Okay. I don't know what the slope is. Is it 1 or is it something negative? Because look, you have both parts. You have the positive part and you have the negative part, right? It's a different slope. We actually call this a corner. And what the deal is, we don't know what the slope is. That's why this slope is an open dot. Okay? Because it's a hole. I'll write that. It's actually a hole. That's the better word, right? It's a hole because I don't know what the slope is. So when it changes, when there's a corner there, I do not know what the slope is. Okay? So that's good. What's the slope between 1 and 2? Well, I go down 2 and over 1. So the slope is negative 2. So at negative 2, I draw my graph. Right? So see, it jumped from 1 down to negative 2 because the slope did jump. In fact, what type of discontinuity is this? It is a jump discontinuity. You guys should recognize that. Okay? And don't tell me it's a point discontinuity, because a point discontinuity literally is if there's a hole in the graph. But this is a jump discontinuity. Okay? What's the slope between 2 and 3? The slope is 0. Okay, what about between 3 and 4? It's 1. That's pretty easy, right? That's not bad. The slope between 4 and 5 is negative 2. The slope between 5 and 6 is 0. Okay, between 6 and 7 is 1. Between 7 and 8 is 0. Between 8 and 9 is positive 2. And between 9 and 10 it's down 2 over 1, so it's negative 2. There you go. That was pretty easy, right? If I had my easy button, I'd push it. All right, that's not bad. All right, so here's one. Why don't you guys try it on your own as you're watching this video? Kind of a crazy one. Try it on your own, and then you can even scroll. I'm going to do it right now, but you can scroll through the video and just literally just look at the end result and see if you got the same thing. Okay. So let's set it up here. I'm going to label this 0, 1, 2, negative 1, negative 2, 2, 1. Well, this actually goes up to 3 here for the slope. 3, 2, 1, 0, negative 1, negative 2, negative 3. Okay, what's the slope at negative 2? let's hear this. So let's label these two. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So the slope from 0 to 1 is 0. It's a 0 slope, right? It's a horizontal line. So that slope is 0. The slope between 1 and 2 is up 1, 2, 3. Oh, it's 3. Okay. Okay. These are both open dots. They look a little closed, but they are open dots. The slope between 2 and 3 is -1. The slope between 3 and 4 is up 2 over 1, so it's 2. The slope between 4 and 5 is down 3 over 1, so it's -3. Slope between 5 and 6 is 1. Slope between 6 and 7 is -1. Slope between 7 and 8 is up 1, 2, 3. Slope between 8 and 9 is down 2, so it's -2. And the slope between 9 and 10 is -1. Okay, so hopefully you just check this right now and you're good to go. That's pretty easy. All right, so the second part to this, math fans, is I'm going to give you the slope, and you're going to come up with the original graph. Okay, so let's kind of label stuff again here. Help you out a little bit. This is 1, 2, 0, -1, -2. So 2, 1, 0, -1, -2. Okay, so you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. All right, very good. So now some of you guys are saying, well, let's see, the slope for the first one is, oh, I missed this. This is 1. The slope for the first one is 1. And you're like, well, I don't know where to start, though. I don't know where to start either. So here's the deal. Sometimes I'll actually give you a starting point, and then you're good to go, or you come up with your own starting point. I'm just, for the heck of it, I'm going to start at 0, 0, because I think it's just a nice, convenient spot to start. So the slope is 1, and so I'm going to go from, I'm going to start again 0, 0, and the slope is 1. Okay? And the slope from 1 to 2 is -1. So it's down 1 over 1. And notice there's not a, you don't put an open dot there because the slope does jump, and I certainly have a corner right here at 1, right? The slope is, it's going from a positive to a negative. Okay. From 2 to 3, the slope is 2. So at 2, I go up 2 over 1 from that point, right? So there's my slope 2. And then from 3 to 4 is -1. So down 1 over 1. Plot the point. Go. The slope from 3 to 4, from 4 to 5 is -2, so down 2 over 1. The slope from 5 to 6 is 1, so up 1 over 1. The slope from 6 to 7 is 0, so I goes this. Oops, it's right here. It's 0. Slope from 7 to 8 is 1, so up 1 over 1. Slope from 8 to 9 is 2, so you go up 2. So it's actually, I'm going past this, up 2 and over 1. So up 2 and over 1. So this is actually, I kind of almost need to extend this, don't I? It's okay. And then from 9 to 10, the slope is -2. So down 2 over 1. There we go. That's the graph. Okay? Pretty easy. So here's one to try by yourself. So give that one a shot. And again, just do it and then come back and check with me. I'm going to label my axes here. So I didn't label this before, but this of course is our slope axis. And this is just our y-axis here, right? And then remember, x-axis is normal for both of them. So let's label it here. 1, 2, 0, -1, -2, 1, 2, 3, 0, -1, -2, -3. Okay. Right. So the slope, I guess again, I'm going to start at 0, 0, because I think that's an important, nice place to start. Okay, so 0, 0, and then the slope is 0 for the first shot there. So I'm just going to literally go straight across. Okay, and then the slope is 1, so I go up 1 over 1. Then the slope is 2, so I'm going to go up 2 over 1. Then the slope is -1, so down 1 to the right 1. And then the slope from 4 to 5 is 0. So I just go straight across. And then from 5 to 6, the slope is -1, so down 1 over 1. And then from 6 to 7, the slope is -2, so down 2 over 1. From 7 to 8, the slope is -1, so we go down 1 over 1. From 8 to 9, actually from 8 to 10, now this is tricky, a little tricky. 8 to 10, the slope is 1. So don't just go up 1 over 1 from 8 to 10, it's from 8 to 9, right? The whole thing is a slope of 1. So from 8 to 9, I go up 1 over 1, and from 9 to 10, it's 1. So the slope of the whole thing is 1 from 8 to 10. Now here's what people want to do. People want to go, they want to put an open dot at 9. There's no open dot there. The slope is consistently 1 from 8 to 10. So up 1 over 1, up 1 over 1. So it looks like this. Okay, so it's just a solid line because there's no change in slope there. Okay, so kind of watch out for that. If you kind of going back to, real quickly, if I go back to this right here, and if I gave you, let's go, I'm sorry, we need to keep going all the way back here. If I gave you a slope that was continuous, let's just say one of our slopes was from 8, let's say from here, 7 to 8, it looked like this, like that, a solid line like this. Okay, you're not going to put an open dot here because there's no corner there. It's a solid line. So from 7 to 9, what you would do is you'd say the slope is up 1 over 1. So you would do this from 7 to 9. 7 to 9, you would do this. Okay, does that make sense? Because it's not changing. There's no hole here because it's a solid line and a solid straight line. There's no corner. Okay, so that's just kind of a little tip there. Okay, so now we are good to go with graphing. The last thing I want to do here is actually a pretty important part of calculus. It's something called average velocity and instantaneous velocity. Now, you actually know how to do a lot of this stuff, okay? So this is, some of you guys are going, what? This is like hard stuff. What are you doing, Mr. Curvis? We've already seen this, right? Average velocity is basically, we're going to use average rate of change. If you remember, one of the problems we did back in the day, when we did AROC, sounds like the missile launching, right? Oh, it launched the AROC. Okay, or if you're on the beach and you're walking by and you see something really nice and you point to something on the beach and you go, hey, look at that, there's a rock. Okay, whatever. You probably say there's a shell. Anyway, whatever. So you have the average velocity, which is average rate of change, is just change in position divided by change in time. That's all it is, okay? Instantaneous velocity is, we've learned it using the derivative, we learned it with the slope. Remember when I did with the Mustang, where, let me make a quick sketch here. If you guys remember, like this is the old Mustang problem. And remember when I wanted to find the average rate of change at like this point right here, I would pick a point on either side, and I would do the average rate, again, using our nice little friendly formula here, right? Okay, and then I said, well, what happens when that gap gets smaller and smaller and smaller, and you're actually right here, right? And all of a sudden, I'm trying to find this slope. So that slope was the instantaneous velocity of the Ford Mustang. So that's all you're doing is we're not even going to do the limits for this one. We are literally, when I'm talking about instantaneous, we're going to look at slope. Okay? Very, very simple. So let's actually get started with a problem here. It's quite simple. The position of an object in feet is given by the function s of t is equal to 3t minus 4. Find the average velocity of an object over time between 0 and 7 seconds. So what you're going to do is you're going to say, again, it's change in position, and so it's basically, you're going to say s of 7 minus s of 0 over, so that's your position function, plugging the 7 and a 0 over change in time, which is 7 minus 0. That's it. Again, this is AROC, or average velocity. Okay, it's average rate of change or average velocity. Okay, so we're just going to plug in a 7 into this thing. Now I like using brackets because it makes it a little bit easier to keep everything separate, especially with this negative sign here. Okay, so just be careful about that. So I'm going to say basically 3 times 7 minus 4, close bracket, minus 3 times 0 minus 4 over 7 minus 0, which is 7. Okay, so let's just kind of plug it in. 3 times 7 is 21. 21, which is my favorite number in Vegas. Oh yeah. 21 minus 4 is 17. So that's 17 minus, and 3 times 0, of course, 0, minus 4 is negative 4. Okay, over 7. So it's basically 17, double negative, so 17 plus 4 is 21. Hey, back to my favorite number. So 21 over 7. So my answer to this one is 3. And the units for this one, because it even says it's given in feet, and this is over seconds, so it's 3 feet per second. Okay, that is the average velocity. Instantaneous velocity, remember I told you, I even highlighted this guy here, it's slope. So the beauty of this, math fans, I don't have to do limit. If it's more of a complicated problem, I will have to use limit, because if it's like a square term, but I'm not even going to give you, at least for this specific day, I'm not going to give you anything more complicated than something linear. So if you look, what is the slope of this line? You guys learned this back in Algebra 1, probably 8th grade, 7th grade. The slope of this line is 3. What? So my instantaneous velocity is at 3 seconds. It doesn't even matter what this is, because my slope for the equation, I'm just going to write this, y is equal to 3t minus 4. It's really right 3x. I'm just trying to give you an idea, right? The slope is whatever's in front of the x. So my average, or my instantaneous velocity is 3. It's this guy right here. Okay, so that's it. You just get the slope, and so it's 3, what do we say, feet per second. That is my instantaneous velocity. What? That's it? That's kind of nice. Oh yeah. All right, so the last problem is the same thing, except now you have an absolute value. All right, and you're like, what do I do with absolute value? Well, remember, with this function, if I want to kind of quickly sketch what this function looks like, it looks like this. At 5, it's a downward absolute value. So actually, I have 2 functions. Okay, so I've got to figure out, now the first part's easy. I just plug in a 0 and a 4. But the second part, I have to figure out the slope. Now, is it this line? Or is it this line? Okay. Well, we'll get to that in a second. Let's do average velocity. Again, it's going to be s of 4 minus s of 0 over 4 minus 0. Okay, so let's plug that in. If I put a 4 in there, I get negative 2 times, and let's put the 4 in there now. So 4 minus 5 is negative 1. Absolute value of negative 1 is positive 1. Okay, that's cool. Minus negative 2 times, and then if I put a 0 in there, I get 0 minus 5 is negative 5. Absolute value of negative 5 is 5. So it's negative 2 times 5. And that's over 4. Okay, so negative 2, the top one, or the first one gives me negative 2. I'll still put it in brackets here just to show all my work. and that one gives me negative 10 over 4. And then, of course, I have double negative again, so negative 2 plus 10 is 8 over 4. So my answer is 2 feet per second. That is my average velocity. Okay? And instantaneous, now remember I showed you this graph and you're like, now which one is it? Is it this guy right here, or is it this leg here? So how can you change an absolute value function to something that you actually know, like that doesn't have absolute value in it? If you guys remember, we turned it into a what? Ta-da! Piecewise function. Piecewise function. That's what you got to do. So hopefully you remember that. That's literally from the last calculus chapter. So let's change that into it. Let's keep the function here. So basically, if you remember, I'm going to say S of t equals, and I'm going to put a kind of a squiggly bracket here. And remember, first of all, our critical point where it's changing from a positive slope to a negative slope, or our vertex, is at t is equal to 5. Because if you look at it, it's t is equal to, here's the equation, and t is equal to 5, or it's t minus 5 equals 0, so t equals 5 where it's changing. So what I'm going to do with that is I'm going to say, and let me write this a little bit farther over here. T is greater than or equal to 5, and then you're going to have a t is less than 5, right? One of them is greater than or equal to, or equal, doesn't matter which one goes with the equal to sign. Okay, and then remember, you're gonna, for the actual function, you're gonna keep the same sign. Remember that. Keep the same sign. So it's negative 2 parentheses t minus 5. And for the less than, you're gonna change the sign. So positive 2 times t minus 5. Okay? Hopefully you guys remember that. It's really not difficult. So for the greater than, you keep the same sign. For the less than, you change the sign only of the stuff in the absolute value. That's important if you remember that. So if this was like 5 minus 2 absolute value of t minus 5, that 5 just stays the same. It doesn't change. Okay? So let's simplify this. S of t is equal to, it's negative 2 t plus 10. Try to make my t's look like t's. Plus 10 when t is greater than or equal to 5. And positive 2t minus 10 when t is less than 5. Okay, now we're good to go, math fans, because here's the deal. I told you what's going on at t is equal to 7 seconds. Because you're like, well, which equation do I use? Remember, I'm using the slope. So you look at this guy right here, and you're like, oh, when t is greater than or equal to 5, and we actually ignore the equal to for this, to be honest with you, because if it's equal to, you're at a corner, and there is no slope there. Right? So at 5, greater than 5, your slope is what? Negative 2. And when it's less than 5, your slope is just 2. So I look at this t is equal to 7 seconds, and at 7 seconds, it's certainly greater than 5. So my instantaneous velocity is equal to what? It's equal to negative 2. So negative 2 feet per second. That's it. That's what you do. Now, if I gave you the same problem and I said, hey, what about at time is equal to 3 seconds? Well, okay, now you look at this one right here. When it's less than or equal or less than 5, and you would say your instantaneous velocity is equal to positive 2 feet per second. Okay? So just know how to do this. You will see this again in calculus. It's on the final exam. Obviously, it's on the test that's coming up. So you will have to figure out average velocity and instantaneous velocity just using what I just taught you guys now. And then, of course, you have to, and you got to, just kind of going back to all the graphs, got to know how to do the graphs too. Okay? That's it, math fans, for calculus. Actually, our last day for calculus. So you have an outstanding day, and stay out of trouble. Adios, math fans. Goodbye.